For this experiment, we're gonna need balloons, skewers, petroleum jelly, and a freezer. First, we're gonna take 2 balloons. You can mark them with a Sharpie, or you can pick 2 distinct balloons so that you remember that these are the ones that we're gonna put in the freezer. We're gonna let those guys hang out and chill for 2 hours, and then we'll come back. We're gonna take 2 different balloons, and we're gonna leave these room temperature. A room temperature balloon and blow a breath of fresh air into it. Was that a little hard? What did we keep blowing? Did it get easier? I wonder why it did that. Is it getting harder or easier to blow up the room temperature balloon? Let's write that down. Now we're gonna let that air out and take some deep breaths to get ready to continue to try this experiment out. Now that our balloons have chilled, let's test them. Is it harder or easier to blow this balloon up? To make a fair comparison, we're gonna do it again. Alright, so now you're gonna take your petroleum jelly and put some on a skewer. You're gonna blow a balloon up 2/3 of the way and tie it. And then you're gonna take your skewer and you're gonna think about, where could I poke this and the balloon wouldn't pop? Would this be a good spot? What about here? Try it out and let me know how it works for you. I don't know.
Yes.
Okay. Did that work for you? I was nervous, but it worked. I was shocked. If it didn't work, try it again. If you notice that the balloon is darker here, that means it can stretch more. So maybe this is the best spot. If you poke it here, the balloon is thin and easily going to pop. So, what happened? Did the cold balloon require more effort to blow up compared to the one at room temperature? Did your balloon pop when you poked it in the spot where the balloon was stretched taut? It's expected. The particles of cold materials move and wiggle less and can hold on to each other more easily. As a result, the cold balloon resists being stretched more than the warmer one does. That's why it was so hard to get that air in there. Did you observe that the balloons that were blown up with only a few breaths regained their original shape and size when the air was let out, while the one that was blown up completely did not quite gain its original size? This is typical for elastic materials. If we had blown even more air into the balloon, it would have eventually broken. Think about it like stretching a rubber band. If you stretch it really wide and then cut it in the middle, the 2 ends are going to snap and pop back, right? In a similar way, the small hole in the taut surface snapped the ends back. This pull tore the surface of the balloon open in an instant, and the balloon was torn into pieces in the air, and all the air rushed out, creating a shock wave, which you could probably hear as a loud bang. But when you poke a sharp object into a place where the material can still stretch, I thought this would be close to the knot, right? Or somewhere near the top. You can pierce it without destroying the balloon, and it doesn't pull back or create a huge hole, so it doesn't tear the balloon open. And the petroleum jelly helped to seal the hole, so our balloon was still intact. Did you have fun today? Alright, I hope you had fun today. Remember, always be kind. And if you're going to be kind, throw that kindness like confetti.